Great. Thank you very much. Can you hear me well?
Yes, we can.
Great. So thank you for the invitation. My name is Olivier Starkenmann. I'm the co-founder of OVO Urban Logistics. We are micro-logistic Swiss-based startup. I'll present to you today an aspect, the logistic aspect of the project Ultimo. So to give you a bit of context, the project Ultimo is quite a large project in terms of deployment of AV buses for passenger transport. There is 3 demo sites, one in Oslo, one in Erfurt, and one in Geneva. In the demo site in Geneva, we are adding this logistic component that is quite a small component compared to the whole project. So there's a lot more partners in the complete project. I invite you to go see online what is Ultimo. And I'll focus really on this logistic side. So what we are doing there, we're doing a dual usage of AV buses that are made for passenger transport, but we also offer now service for transports, for logistic transport. The challenge is that PTOs, so public transport fleet owners, when they have an autonomous vehicle, they might have bigger fleets, and the investment in an autonomous vehicle is quite high investment, but then the operating costs are quite low. So the challenge is how can they amortize this large investment? Our idea is to maximize the usage of these AV bus over a 20-hour cycle. So the solution we're coming with in this project is that we are testing logistic operation services during off-peak hours of passenger transport. So that means when passenger transport demand is lower. We're never combining people and goods at the same time, it's at different times. I want to present to you a small overview of 2 use cases that we have identified. So in this project, we're really trying to deploy services. So we're not only doing pilots, we really have to have a real life services ongoing for logistics. So based on a lot of different limitations, we have boiled down to 2 use cases. One is what we call autonomous pickup. So what we're doing is we're connecting supplier with central warehouses. It can also be used for intra-site shuttles, so intra-logistics. The other use case that we would like to present to you today is what we call mobile nano hubs. This is a bit more innovative, so we will take a deep dive into it a bit later. This is a solution more for multimodal urban logistics. So I'll share with you a small video and I'll comment it at the same time. So the first goal is that the vehicle can autonomously pass from passenger transport to good transportation. Then the idea is that the vehicle goes to a point of production, so a supplier, and comes to do a pickup. What we can see is quite important is to have all systems connected so that the supplier can easily load the vehicle and knows when the vehicle comes. Why is this? It's because often it's the transporter that sends the vehicle to his clients. So the producer is his client, so he doesn't want him to lose time. And then we're connecting this supplier or this point of production to a central warehouse. So this warehouse is a warehouse of a transporter or any logistic operator. So what we just saw is an optimization of operation upstream from what we call warehouse, logistic depot or warehouse. So we're upstream in the supply chain. And it's quite clear that that is normally managed by transporters and not directly by the end client. The output of this use case is to offer a more flexible time window for the collection of goods to the final clients, which are the producers. Now let's have a look at the second use case. The second use case is about bringing goods closer from the center of the city. So here we're starting again from a warehouse, so a central warehouse, and we're dispatching the goods. At the same time, we're giving the information to a courier that the goods are arriving at a certain parking. So here we call it a mobile depot. So you see a courier that is working in the city. He received a notification that he has to come and pick up the goods. He picks up the goods, offloads it, announces that he offloaded, and the AV is free to go, and he continues to do his delivery to the final customer. The AV automatically switches back to passenger transport and is free to go do some passenger transport. So maybe it's crashing a bit. Let's wait. Can you see? I don't know which screen do you see?
We see the My Mobile Nano Hub, but it's stopped. Now it's starting again.
Okay. Give me 2 seconds. It will.
It's paused, but maybe.
Yeah, it's just
play it
lagging.
again. Okay.
It's we just have to be patient. We're almost there. So let me comment. Can you hear me?
Yes, we can hear you.
Great. So as you see, we're focusing on B2B models. So why is that? It's because in this project, we have to deploy a real service. So today, every handling, any unloading or offloading is made by a human. So we need to be able to manage this. So it's hard to have a B2C solution. Okay, so now it's moving. There we are. Back on track. Sorry for this. So what we just saw is what we were calling the mobile nano hub. So we're downstream from the warehouse. And what we're doing is we're doing direct cross docking for another kind of vehicle to take over the goods for the final delivery. But why are we doing this? As you know, the cities have quite high ambitions in terms of CO2 emission reduction, also in terms of congestions in the center of the city, and they are limiting the access of the center of the city for logistic operators. This is a problem for logistic operators because having their hubs out of the center of the city, since their central hubs are quite big hubs that needs large surface, they are not directly close from the center. And having small vehicles with small volume doing empty returns, it's really not efficient for logistics. And knowing that last mile represents between around 40% of the logistic costs, it's very difficult for logistic operators to adapt. So what we're proposing there in the approach is really to have the AV that is doing the work to bring closer the goods from the center of the city. This approach is not coming from nowhere. It's all the work that OVO is doing on this subject. It's about having decentralized urban logistic and a multimodal urban logistic. But today what we're doing is we're having fixed depots that are connecting trucks to cargo bikes. And here the idea is to replace the fixed depot, as you see one on the left, that we call a nano hub, with autonomous vehicle that can just park in a more flexible way in parkings that are free space in the city, and he just have to communicate his location to the cargo bike. So it's quite a nice solution to be efficient in terms economically and also in terms of usage of the square meters in the center of the city. Now, I just wanted to give you a few challenges that we were facing when we were doing the first test. An autonomous an AV needs to know his environment. So you need to map the streets. You need to map every square meters where he goes. And in a B2B process, you have to enter warehouses. So how do you map all the warehouses that you want to enter? This is quite a challenge. Also, you have to be sure that you have the GPS signal that goes through the warehouse. If it's a secured warehouse, it can become quite complicated. So the AV doesn't know how to drive into these warehouses. As we also discussed, there is all the handling automation. So going forward in this project, we can imagine have an automated loading and unloading and offloading process. But today we're doing it with humans. There's also a question of containerization. As we saw in the other presentation, there are a lot of different ways to have containerization and to manage goods. The challenge in this project is that we're using vehicles that are made for passenger transport and not for person transport, and that they are quite small. So there is a whole work on having the right containerization that's to secure goods and to also respect cold chains. But you also need the last mile vehicle that are adapted to these kind of containers. Another challenge that is quite an important challenge is you have to find logistic demand on these off-peak hours. In fact, the main focus of the vehicles are to transport passengers. So in this case, we have to find logistic demands that are in the evening, at night, or in some very precise time slots in the day. Another challenge is to be able to adapt between two kind of orders. So could be some dynamic order where you need an automated vehicle and you order it for the next hour for a precise mission. And the other type of order is to have a planned order. So normally what happens in logistics is that the transporter, he knows in the future that he needs for 3 months or 6 months this certain capacity, a certain amount of vehicles to execute a task. And in this case, we really need to be able to pre-plan this so we're sure that the AVs are available for logistics. How we are building our service today? We have in very simple three different layers. So the first layer is for sure a booking interface. We need to have the logistic operators that can order the vehicles. We need quite a new layer in the different approach that we have been seeing. It's what we call an orchestrator of the logistic service. So we need someone that is able to manage the booking rights. It's kind of a broker that can manage the contracts. If there is a contract on long term with a certain logistic operator, to be sure that he has the availability of the vehicles. And then this layer has to communicate with the fleet orchestrator. So for the people that are not used to AVs are like computers on wheels. So the fleet orchestrator is the mind of the computer, really, of the AV, and is doing the optimization of the route and is sharing the real availabilities of the vehicle and is able to give you time to destination when it arrives, and all you need to execute the mission. That was quite, I hope it was quite short enough. Thank you for your attention, and it was looking forward for any question.